This question area, a ball is thrown vertically upward from a height with a speed of 12 meters per second as shown in the diagram below. Calculate the time it takes for the ball to return to its starting point. Ka gore bona this object ba latlha godimo ka the initial speed of 12 meters per second. Re tseba this object yo reach a maximum height before e ya fast. And then another thing o gonna bona this object at this point they on the same level. This means this initial speed yo lekana le the final speed at this point because they on the same level. Let's say if we choose upward is positive. If we choose up is positive, this means our global something like, and then downwards it will be negative. Therefore our acceleration it will be downwards and then it will be negative. Because this object is positive, because upward is positive, this means we are in the positive direction, and then we are in the negative direction. So this speed at this point you are negative. So now the initial velocity and the final velocity at this point because this object on the same level. And then another thing here is about the time it takes this object or if it the maximum height. You only can know the time it takes for this object to come at this level. Hello, this object from here towards the maximum, if it's like a 2 seconds, error from this maximum of it at this point it's over 2 seconds because this object is on the same level. Now I'll answer this question. Calculate the time it takes for the ball to return to its starting point. Re tlo lebelela a formula ile gore re na le time and then e ka suta the information ye re na le yona. This formula it will be applicable. VF here it's negative 12 and then our initial speed is 12. Our acceleration it's negative 9.8 and then from here nyaka time re ka 12 right to the other side ya change also then rabal negative 24. And then from here we divide up both sides by negative 9.8. This means our time will create 2.45. Key this time right from this initial point if it to this point. Our level part B. Part B is sketch a velocity time graph from the time the ball is projected until it returns to its starting point. I think this one is easy. Re tsaba always on the y-axis ke velocity in meters per second, and then re tsaba on the x-axis ke time in seconds. From here on the y-axis, because this object the initial speed is 12 and then ke positive, this means our initial speed is over here over 12, and then this object if it on the maximum ka a certain time, so more tongwala the time it takes to reach the maximum height. But remember our time recreator is 2.45. Yeki get this object right from this initial point if it on this same level, and because the time it takes to go up like the time it takes to come down, this means this object if fitlile mo godimo ka half of this time. So ge re nyaka go tseba re this object if fitlile ka bokae mo godimo, re tlo re 2.45 divided by 2, and then e ra re mo re tlo ngwala that time. So 2.45 divided by 2 e re fa 1.225. So this means mo re tlo ngwala 1.225. Remember, this point always get the time it takes to reach the maximum height from the point of projection. And then this question is sketch a velocity time graph from the time the ball is projected until it returns to its starting point. This object more get the starting point, get the same level at the starting point. So this means this object ya godimo and then ya buya at this level. So re tlo nyaka the velocity at this level, and then the the velocity at this level is -12. So this means this object ya tswela pele, and then at this level ra ba le velocity ya -12. So re tlo tshwanela gore re ngwale time for this one, but re a tseba gore this object e fihlile mo go velocity ya -12 meters per second ka the time ya 2.45. So this means more our time re na le 2.45. ke this velocity ya this object ya mo go -12 re kry gore ke 2.45. So this is our answer for part B. And then this one area, a ball is dropped from the top of a building 30 meter high and hit the ground with final velocity of 24.25 meters per second. Calculate the time it takes the ball to reach the ground. Normally something like this one. Let's say this is a building, and then where this object is dropped, and then where this building is 30 meter high. That's where if this object is dropped, this means certainly the initial velocity is 0, and then where the final velocity. Let's say if regia upward is positive. If regia upward is positive, this means our downwards is negative, and therefore our acceleration it will be negative. A re lebelle a formula e le re ka kgona go šomiša go calculate time. This formula re ka kgona go šomiša. Re na le final velocity ya 24.25, but remember re upward is positive, and then this object ya fase ka mo godimo ke positive, and then ka fase ke negative, and then this object is dropped. This means in the negative direction, therefore re tlo beya negative. Our initial is 0, and then our acceleration it's negative. And then from here, because this is 0, this value, and then we divide both sides by -9.8. Therefore our time we create 2.47. So give the time we reach the ground. So question area part B, sketch the velocity graph for the motion of the ball. This one it's easy and straightforward, because regia upward is positive. This means the acceleration it's negative. So because acceleration is negative, this means we expect this slope or this shape draw our graph. So because this object is dropped and then the initial velocity is 0, this means you're here, and then moyaba the final velocity hit the ground. So the final velocity, it is 24.25, but because it's in the negative direction, you have a negative 24.25, and then you get time hit the ground. So this means more than 2.4 second, 2.47. So this is our answer. This example area, a man fires a projectile X vertically upwards at an initial velocity of 29.4 meters per second from the edge of a cliff of height 100 meter. After some time, the projectile lands on the ground below the cliff. The velocity time graph below, not drawn to scale, represent the motion of projectile X. Ignore the effects of friction. Are draw this motion. This building was 100 meter high, and then where a person o lahlela an object kwa godimo, and then this object where e boya fase on the ground. A re lebelle this velocity time graph. Re a tseba gore on the y-axis, our y-intercept ke the initial velocity ya the object, and then already ba re file gore the initial velocity ke 29.4 meters per second. So re a tseba gore re na le 29.4 meters per second as our initial velocity, even if e ba se ba re botša. And then another thing re a tseba gore this x-intercept ke the time it takes the object or fihle the maximum height. Remember this object you fihle the maximum height pele before e fihla on the ground. This object you fihla this height ka a certain time. So that time ke this one, ke the time it takes to reach the highest point. So this means for part A, it use the graph to calculate the time that the projectile takes to reach its maximum height. So this means the answer for part A is 3 seconds. This part always the time it takes to reach the maximum height. So this object it and then you reach at this height ka a certain time. So that time it is x-intercept always. And then part B, it calculate the maximum height that projectile X reaches above the ground. This question inyaga this maximum height. Of it on the ground. So don't worry about velocity time graph. Re tseba gore this part this area o ka kgona bona this is a triangle. For this triangle re ka kgona find out the area ya this triangle, and then ra kgona tseba gore this object height ya yona ke bokae from this initial point ya ge ya godimo. Ra nyaka tseba gore this height ke bokae, because ga re ka tseba this height re tlo tseba gore from here to here ke bokae, because already mo re a tseba gore re na le 100 meter. Always ga o nyaka go find the height from the initial point to maximum point, or shumisha the area ya this triangle. Remember this area re na le the initial velocity ya 29.4, and then this initial velocity ke this object ge ya godimo, and then this time ke ge this object e fihla kwa godimo ka this time. So re ka kgona go find this height ra shumisha the area. So for part B re tlo shumisha the area ya triangle because this is a triangle. And then from here our base ke this one ke 3, and then our height ke this one you about 29.4, and therefore our answer ke 44.1. So because re nyaka the maximum height from this level, error 100 plus this 44.1, probably 100 plus 44.1, therefore create 144.1 meter. So ke answer ya rena ya part B. And then this one area, the velocity time graph below describes the motion of an object that is projected vertically. Study the graph, answer the following question. O ka lebelela this velocity time graph, ba re file the initial velocity because re tseba always on our y-intercept re na le the initial velocity, and then re tseba gore this x-intercept get the time it takes to reach the maximum height. Let's say re na le this object ba ilahlela godimo, and then let's say ya fihla fase again. Re tseba gore this object gore e fihle this height yo fihla ka a certain time, yo fihla this height ka a certain time, and then this x-intercept ke the time it takes or this object e fihle mo godimo. So this question area, after how many seconds the object reach maximum height. So era gore ba nyaka the time ya this object ge tloga mo e fihla the maximum height. And then let's say if we choose upward as positive, if we choose up as positive, our acceleration is downwards, and then it will be negative. And then from here re ka kgona calculate the time it takes for this object to reach the maximum height. Remember gore this object at this height final velocity is 0. Always ra tseba gore the velocity at the highest point is 0. So re ka kgona shumisha this formula. Ra tseba velocity at the maximum height at this point is 0. Remember this question in nyaka the time it takes this object or fihle this maximum height. So ra tseba gore at this height velocity is 0, and then re na le the initial velocity at 20. So ke positive because this object ya godimo in the positive direction. Our acceleration it's negative, and then re nyaka time. Re tlo tšea 20 re tliša to the other side, and then from here re tlo divide both sides ka negative 9.8, and then re tlo kry-a time ya 2.04 seconds, and then this is our answer for part A. A re lebelele part B. Ere, what height above its starting point does the object reach? This question e nyaka this height ya ge this object e fihla this maximum height, and re tseba go find this maximum height re ka kgona shumisha the area. Remember mo re na le a triangle. This is the initial velocity ya this object ge ya godimo, and then mo ke time it takes for this object gore kgone fitlhella the maximum height. Re findile gore time ya this object ge fihla this maximum height ke 2.04 seconds. So re tlo shumisha this area ra kgona go kreya this height. This time ke 2.04 ke age this object e fihla the maximum height, so re ka kgona go kreya this height re shumisha this portion ya area. Therefore, to answer part B, one over 2 base times height ke area ya triangle, because now re dira le triangle. And then obvious our base it over this one from here to here ke 2.04, and then our height ke 20 ke this one. And therefore our answer ke 20.4 meter. This is our answer for part B. A re lebelle part C. After how many seconds after its launch does the object hit the ground? This question e nyaka the time ya this object e tloga moke, e tloga from its initial point e fihla on the ground. According to this question, this object ile godimo ya boya fase on the ground, so ro nyaka the time o fihla on the ground. Go ka lebella this velocity time graph, o ka kgona bona gore re na le the initial velocity, and then this object ya fihla the maximum height ka 2.04 seconds, and then ya fihla on the ground. This velocity ke ge this object e fihla on the ground. O ka lemoga gore now 20 and negative 40 ga di tshwane. Ge be ile gore mo re na le 20 and then mo ra ba le negative 20, e be tlo ba gore this object ke velocity ge fihla here, because re a tseba re velocity at the same level di a lekana. The only difference is the signs. But now because this is not negative 20, era this object e fitile this portion ya fase ya hit the ground. Therefore era this is our final velocity ya this object ya hit the ground. And then from here era re na le the initial velocity ya 20, re na le the final velocity ya negative 40 ya this object e hit the ground. Remember this VF is negative because re choose your upward ke positive, so this object here we are fast, obviously we are in the negative direction. Then from here re ka shumisha this formula. Re na le the final velocity, our initial velocity re na le yona gore ke 20, and then from here re ka tšea this number re tliša to the other side, it will be minus 20 minus 40 ya ba minus 60. And then re divide both sides ka negative 9.8, and then our answer is 5.92, and then this is our answer. This example area, a girl is standing on the top of a building. he throws a ball vertically upwards with a velocity of 12 meters per second. It takes 3 seconds for the ball to hit the ground. Go ka lebella this example, ga se ba re drawela a picture. So every time ge ba se ba drawela a picture, when I draw a picture, gore kgone bona nto eo deal le yona. So ge re draw a picture, re tlo ba something like this. Ere a girl o lahlela object kwa godimo, and this object ya fihla on the ground. It's obvious gore this object before e fihla on the ground, yo fihla the maximum height. This girl o lahlela this object godimo ka the initial velocity at 12 meters per second, and then it takes 3 seconds for the ball to hit the ground. Part A ere calculate how long it takes the ball to reach its maximum height. This question nya go tseba this ball yo fihla this maximum height ka how many seconds. So ba nyaka the time. Re tseba gore this object ge fihla at this maximum height, the velocity is 0. So era rena re na le the information, re na le initial velocity, re na le the final velocity at the maximum height. And let's say re choose upward as positive, because always re choose a direction. If re choose upward as positive, this means downwards is negative. And re tseba gore acceleration is always downwards. So this means our acceleration it will be negative because it's in the negative direction. Part A, re find time. Ya this object if it at the maximum height. Re ka shumisha this formula. And then re na le final velocity ya this object if it at the maximum height. It will be 0. And then re na le the initial velocity at 12. It's positive because this object ya godimo in the positive direction. From here nyaka time, re tlo tšea this 12 right to the other side ya ba negative. And therefore re tlo divide both sides ka negative 9.8, and then our time ya re fa 1.22 seconds. This time carry this object if it this maximum height. Now our level part B. Part B it calculate the height of the building. Part B inaga this height at this building. And then re tlo level a formula e le gore ena le the height, and then ena le information e le gore na le yona. So re ka shumisha this formula. And then re na le the initial velocity, re na le the time. Re na le the time here this object hit on the ground, which is 3 seconds. Remember this object, this building it thoma on the ground. So re tlo shumisha this time here this object hit the ground. Re ka shumisha the time here re kry ya 1.22. Therefore the initial velocity is 12, and then the time is 3 seconds. And therefore our answer is negative 8.1 meter. Remember re upward is positive, and then this building it's downwards, it below the starting point, and then come off as negative, so that is why it was negative. And remember the displacement is a vector quantity, therefore in a direction. This negative in the direction or our object it's downwards. So our answer is 8.1 meter. That's about this object is downward. So give the answer for part B. And then our level part C. Here draw position versus time graph. Use ground as zero reference. And then remember regia upward is positive. If regia upward is positive, this means value this shape. And then if regia downwards is positive, this means value this shape. So regia upward is positive. And remember this object e godimo ga a building, and then this building is 8.1 meter tall. This object ya godimo ya reach a maximum height. So error mo re tlo ba le a value ya ge reach this maximum height, but ga sanga re calculator that value for this question. And then this question ga sanga specify or shumishe which value and which value gore gona draw ya our position time graph. So mo re ya tseba rena le this height ya ge this object fihla on the maximum from here. So but ga sanga re find out that height, so re tlo tlogela in this way. But re kgone go calculate the time ya ge this object e fihla this maximum height, ya ge this object e tloga from here e fihla this, re kry-ile gore that time ke 1.22. And then re kry-ile the time ya this object ge fihla on the ground, ba re file gore that time ke 3 seconds. So this point ke 3 seconds. Always this ke the time ge fihla the maximum height, and then this one ke the time e fihla on the ground. And remember this question really use ground as zero reference. So era gore o draw ya go thoma from your height, but if question e be really use the top of the building as the zero reference, e be re ka se be something like this one, o bo tlo ba something like and then mo ya ba 8.1, but ya ba negative. Remember gore ke rile ga o nyaka o shumisha ground as zero reference, draw ya a Cartesian plane on the building, and then from here o tla bona gore na le something like this one. So o bo tlo ba le this picture o ka kgona bona re ke ntho ete. So anyway, question really use ground as zero reference. So this means re thoma from that building mo object ya godimo ka yona. So this is our answer for part C. A re lebelle part D. Part D e re draw acceleration versus time graph. Acceleration versus time graph is always easy and straightforward. Remember our jerry upward is positive. If jerry upward is positive, this means our downwards it's negative. And our acceleration is always downwards. This means our acceleration is negative. And then a negative all the way because the upward is positive. Therefore, how do we draw your acceleration time graph? That's about a more acceleration in meters per square seconds. And then that's about on the x-axis another time in seconds. And our acceleration is negative 9.8. And negative obvious eka fast because our choosing upward is positive. And then from here we'll draw this line. And then this is the answer for part D. And then this one a hot air balloon is rising at a constant velocity. When the ball is at a height of 88 meters above the ground, a stone is released from it. The position time graph below represents the motion of the stone from the moment it is released from the balloon until it strikes the ground. Use the information on the graph below. Re tlo tshwanela ko re draw-e a picture ya this hot air balloon gore at least re kgone go bona ntho e re dealang le yona. This means re tlo ba something like this one. This hot air balloon e ya godimo at a constant velocity, and then this hot air balloon is 88 meter from the ground. The stone saber dropped from this hot air balloon. Because this stone se released or dropped, o ka nagana gore so tsamaya in this direction, but se ka tsamaya in this direction. Let's understand why. According to Newton's first law, an object at rest will remain at rest. An object in motion will continue in a state of motion unless acted upon by an unbalanced force. This hot air balloon is in motion. This means let this stone is in motion because this stone tsamaya this hot air balloon. And then because this stone is in motion, e ra gore so tsamaya pele sa ya godimo before se tlo ya fase. Because Newton's first law ge object is in motion, meaning ge object ya tsamaya, e tla no tswela pele ya tsamaya up until go ba le a certain force is stop that object. So that object you stop get the force of gravity, because always force of gravity e gogela the objects on the ground. So re tlo ba le this picture. A re lebelle gore go dira eng ka this stone. Re tseba gore this hot air balloon e tsamaya ka a certain velocity, and then this velocity ya this hot air balloon e ya godimo ke the initial velocity ya this stone ge se ya fase. Because according to Newton's first law, this stone so thoma pele sa ya godimo ka that same velocity e be tsamaya ka yona, and until we ba le a certain force e stop that object. So e ra gore this stone ge re ka khwetša velocity ya sona, e ra re tseba the velocity ya this object, because this object hot air balloon e tsamaya ka a velocity ya tshwana le ya this stone ge se ya fase. Now a re lebelle this position time graph. Re tseba on the position time graph, always on our y-intercept ke the position ya the object mo e thomago e le gona, and then ba re boditse this object is 88 meter from the ground, and then ba re file 88 meter ke ge this stone ba se isha fase. And re tseba gore at the highest point ke this height ya ge this stone se ya go fihla this height, e ra gore ke this 100. But re tseba gore this is a time, e ra gore this is a time ya ge this stone se fihla on this level before se ya fase. And then re tseba gore on this point ke the time ya ge the object e fihla on the ground. Another thing that is important, every time ge o na le this shape ya the position time graph, this means your upward is positive, and then ge o ka ba le this shape, this means your downward was positive. So this means rena gompieno re ka se re choose a direction, because direction ba re file gore is upward based on this drawing. So re tlo nyaka the initial velocity ya this stone ge se ya fase, and then ge re ka kry that initial velocity ya this stone, e ra re tseba this velocity ya this object, because di tsamaya ka velocity 1. Re tlo šomiša a formula e le gore e na le the displacement, and then e na le the information e le gore na le yona. Re ka šomiša this formula. The initial velocity re nyaka yona, remember, and then re na le time ya ge this stone se ya fase, se betha the ground, so ke 6. And then because upward ke positive, this means global negative 9.8 because acceleration is always downwards. And then finally the displacement is 88 ya this object ya fast, but it will be negative because choose your upward is positive. If upward is positive, this means our downward is negative. And then we can this building is below the starting point, so that is why it is negative. And then from here I can solve the initial velocity, and then more probably negative 176.4. And then from here I can this number I to the other side, so probably the initial velocity here 14.73 meters per second. And then this initial velocity carry the stone say fast, so this means velocity this hot air balloon ile kanalia this one. And so this is our answer.